Okay, let's do another question related to gases. Now we're going to think about conditions where a gas is behaving more like an ideal gas compared to when a gas is behaving more like a real gas. Okay, and so if you think of these little particles, right, the gases, let's just say the little circles, and they're moving around in this box. Okay. And the idea is that eventually they kind of collide and hit each other. And when they do, these collisions are meant to be perfectly elastic. They just bounce off each other. That's kind of just what happens because they're moving at a certain temperature and they have a certain velocity. Okay. One of the kind of hallmarks or tenets of this kinetic molecular theory is we're assuming that there's like very little or no intermolecular forces, meaning that the molecules or the particles themselves are not attracted or repelled by each other. So in order for that to happen, I kind of need these things to be really far apart from each other. And that's going to happen most easily when certain conditions are met. Okay, and so if you think about it, part A, I have high pressure and relatively small volume. So if I have a high pressure, they're really bouncing off each other and colliding with the walls of the container a lot. Small volume means the box is really tiny, so they're really going to get in each other's way. Chances are that there's going to be significant intermolecular forces. They're going to be so close to each other they can't help but interact with each other. So under those circumstances, probably this would be the greatest deviations from ideal behavior. So most deviations from ideal behavior, or what we call a real gas. Okay, so not quite ideal. Part B says, what if you have a high temperature and a relatively low pressure? Well, now you have the opposite situation, because if the pressure is very low, that means that they're colliding with the walls of the container pretty infrequently, and they're pretty far apart. High temperature is also good, because they're moving around so fast that they're on average pretty far apart from each other, have a lot of kinetic energy. So this is going to be the fewest deviations from ideal behavior. So this is going to be pretty close to ideal conditions. And the last part says, what if you have low temperature and pretty high pressure? Okay, now you have the exact opposite situation in part B. They're really close together because of the high pressure. Okay, they're colliding with each other in the walls of the container pretty often. And because the temperature is low, they tend to be more like a solid or a liquid than a gas, like condensed phase. Okay, and so this is going to be pretty non-ideal as well. So these are going to be most deviations, which are also going to lead to a real gas or a non-ideal gas situation.